What's up, my friend? In today's video we are going to see how we may control a single phase induction motor, a special or split phase induction motor, by using one relay or by employing one contactor. So in this way we are going to see how we may control the single phase induction motor by using only one relay, which may be the best economical way and efficient way, so that we may be able to perform such system in any given application, whether industrial or maybe for other commercial activities. And this way is economical and it doesn't not require many things. So in this video we are going to see how we may control it either by using the relay or by employing contactor. But when you are going to use a contactor, we need to employ also the auxiliary block, which is attached on the top of the contactor, in order to attain the contact which are needed. The contact which are needed are two, which are normal close contact and normal open contact. So depending on the portion which you are in, whether we have supplied or we have not supplied, then they be determined output depending on how the system is constructed from the supply system. So what we need to understand, first of all, we need to understand how a single phase induction motor. A single phase induction motor is type of induction motor, but which use two windings. The main windings which are used, we have in main winding and auxiliary winding. So in this way, depending on how we have configured the schematic diagram of running this output of the induction motor, it will determine whether the direction we are going to go on, depending on the way you have connected it. So the main thing which need to be taken into consideration is that the auxiliary winding is the winding which determines the direction by which the rotor is going to go on, whether clockwise or counterclockwise. Then that will be determined by the auxiliary winding. So in that way we have to know this. Auxiliary winding always have high resistance than main winding, and also it consists of low inductance than main winding, and this will occur to the main winding, vice versa. Then means that the main winding also have low resistance but have high inductance. So that feature help us to generate rotating magnetic field which are needed, so that they may induce an EMF into the rotor slot, into the rotor coil, so that to attain the magnetic flux which are needed for the opposition, which will result into the direction depending on the direction of the current carrying conductor which is going through on. So as you have seen here, we have two configuration. The one consists of the forward direction, the one consists of the reverse direction. You see that by changing the W1 and W2 of the auxiliary winding, we will be able to determine the direction by which the rotor is going to go on. But the schematic diagram or the wiring diagram of the system, how it's going to be configured on our contactor or on our relay, is above. So you see that we having we having 4 contact, and the fifth one of the coil where we are going to supply so that we may energize our coil. We having 13 and 14, then 45 and 49, those are normal open. Then we having 21 and 22, then we having 32, 31 and 32, those are normal closed contact, means they are always closed except when we energize the coil and the passion changed. So you see that we have connected the auxiliary winding on normally closed contact. So means because they are always contact, if we measure continuity on both end of 22 and 32, we are going to see they are continuous reaction on them. But we are going to shut 21 on 13 and then 31 on 42, so that we may change or we may reverse the passion as you see on the configuration. Then the output which is going to be attained is going to be connected on the main winding as you see, and another one which is going to remain is going to be connected to in series with the capacitor of 50 microfarad, and the one of 300 microfarad, which is connected in series with centrifugal switch which is going to to remove it when the motor have already started, so that we may reduce the amount of energy or voltage or charge which are going to be supplied to our to our winding, so that we may prevent an overcurrent which may occur, which may produce overheating, then overheating resulting